So I've got this new circuit I built. This thing is ridiculously complicated because getting chips right now is kind of a pain in the ass. Like, so I needed a 7805 linear regulator, a 5-volt regulator. Can't get a hold of one of those, so I ended up going to Dollar Tree and tearing one of these suckers apart because these are 5-volt, and that works. And that's just needed to bring the threshold voltage up on the inside of the SR latch here. This is essentially an SR latch. So this is one of those power modules that we have on his back for turning servos and stuff on and off, and these work really good. The problem is these are in-channel MOSFETs. Like, this whole circuit would be irrelevant if I could find one 15 amp P-channel MOSFET, but I can't. They're like out of stock everywhere. Even Gizmos, the junk store I like to go to, didn't have any that were at the rating I needed. So this is rated for 15 amps, but it only switches the negative side. We can't just use this as a latch because when you feed the ground through from anything over here, it grounds it and it turns it on when you don't want it to turn on. So you have to use a bunch of stuff with this. I tried using just an optocoupler. That didn't work because I had no power on this side to feed through the coupler to things. So what I ended up doing is we have our power coming in from the house, right, 12 volts. And that's going to feed in through here. Plug that in real quick. And this simulates power from the battery pack, right? And the power from the battery pack, or from the house in this case, is going to come up through this circuit. You can see there's a LED that's on now, but nothing else is on. Nothing else is on. That's good. It's good. So these two transistors here create a dual channel set reset latch. If you pull off a 1, it's a P channel, which is positive. If you pull it off the other, it's an N channel, which makes it negative. We're using the P side for the positive to go in through on the N channel MOSFETs to turn them on. So what this does is we have this wire going up to the switch on his back here. That's just a push button switch. You click it. That's wired in down here. So what that's going to do is when we close these contacts, it will trigger the latch, allowing this power to flow through the latch. The latch will stay on, and it'll power the MOSFETs separately from everything else, electrically isolated, so that I can turn it off by the MPU when I want it to shut down. And we're going to demonstrate that as well. The optocoupler is on the reset side of the latch, and that's those two blue jumpers there. They go between the trigger and the ground. And then this is completely isolated from the rest of it. There's a 220 ohm resistor, and then these two wires come off and they go to the ground and a pin on the chip over here. This starts low. It triggers high when we want it to shut down. When it triggers high, it turns on the optocoupler, which is what optically isolates the chip, the control chip, the CPU, the ESP32, the microcontroller, whatever you want to call it. They're all accurate. That turns this on, which triggers the reset, which shuts everything off. So we're going to trigger it. We're going to reach back here. We're going to click his button, which we've seen in other videos. Only click it for half a second. It clicks and it turns on. And he's on. He's going to boot up. And after he boots up, we'll give him a command to shut down, and he should shut off on his own. So this is cool. This circuit is just stupidly huge. So stupidly huge. Come on, suppliers. I need a P-channel MOSFET. Quit leaving me hanging. Alright, he's booted up. And you can see he booted from EEPROM, which is nice. He has the save stats from last time we were playing with him. So now we're going to come up to his vocal processor, which is the wireless Bluetooth from the phone. Power off. My hands are here. I'm not touching nothing. Oh, you know what? I bet you I didn't click this over. I did not. I didn't turn the data port on. So the wireless Bluetooth up here goes through the switch so that I can switch it between the main processor and the one that does the head tracking, the facial tracking in the head. I had it set to that one for sending data out to the thing. So now it's hooked to this one, which is this cable here. So we'll try it again now. Power off. And he's off. So now he can turn himself off, but he cannot turn himself on. We still have to click the on button to turn him on. So, fun feature.